Students, so I've already talked about base E being 2.781828, etc. right there, and ln being the number for it. This is how it is actually calculated right here. This is the exact answer to it. This you'll see in calculus. It's actually a calculus question, so you might want to memorize that. Those going on in calculus, 1 plus 1 over n to the nth is what E equals, because that will be like a test question in calculus, what the exact answer of E is, and then that's the answer right there. That's what they want to, that'll save you a lot of time if you memorize that. Okay, to know that that is E. You'll either have that answer or they'll give you this, say, where's that equal? And then the answer is E. And that way you don't have to solve it with logs to come up with that. Okay, you can use logs to prove that. All right. The functions f of x equals e to the x and f of x equals natural log of x are inverse functions. Remember, inverse is when we switch the x and the y. That really is y right now. Okay. So if I switch it, it becomes e to the y equals x. And remember, when I put the natural log there, that base is e, and that says e to the y equals x. Okay. So those are the same. Now, remember here, this is like the log one, e to the natural log of x. Remember, they automatically know, I expect you to know that's e equals x. It's the same thing as I told you before. B to the natural log base b of x equals x, as long as these two are the same. So notice e and e is the same, b and b is the same, the answer is x. Okay, again, we can do that with a proof in class. To prove that, right now I just want you to accept it and use it. And like I said, if you want a proof, we'll do that in class. Or maybe I'll do a separate video on the proof. Okay, write a logarithmic equation. That means it has to have a log in it, equivalent to e to the 2x equals 7. So when you see base e, we want to use ln every time, because that goes along with it. So we're going to say natural log of e. Remember, it's this base to this power, so that's e to the 2x right there, equals this number right here, 7. Okay, we've already done this before with other bases. Okay, now you're just doing the same thing with base e on that particular problem. Okay. That's it. And you don't have to, as beginners, you're going to want to probably put that e there. But as they did, they didn't put it in the answer. Okay, but those are the exact same thing. Okay, just so you know. All right, so you're practicing that again. Right there, write each logarithmic equation into exponential. So we're starting with a log, and we're changing it to an exponential, which means there's no log in it when we're done. Remember, this is base e, so it's e to this power equals that right there. Okay, so e to that power is approximately equal to x right there. Okay, so this is review. So you're practicing that again on this side. Evaluate it. Remember, you could just literally type them in to your calculator and it'll do it for you. Don't forget subtraction. You could change it to division of one log. I could go 943 over 181. Okay, and then this is all in parentheses right there. I want to put it as a single log. That'd be simplifying it. Remember, this is the expanded form when I've written as 2 logs. Okay, so I'll put that in the calculator. It'll give me the same answer as putting that in the calculator. You want to check. All right, backside. equations, now solving them. So again, we solve all equations by reverse PEMDAS. Better knowing how to write this from Algebra 1 in this format. Your Algebra 1 teacher should have taught you. Of course, I taught you if you had in geometry. Reverse PEMDAS. So we add or subtract first, subtract the 2 across. It gives me 8. Next is division, divided by 3. Gives me 8/3. Now I'm stuck. Remember I told you the whole point of having logs is so we can pull the exponent, the variable and the exponent down out front. So every time it's base e, I'm doing natural log. And natural log, whatever, do it on one side, do the other side. Now I can pull this out front, I get 2x. Well, let me write this over here so you can see. So I would have 2x natural log of e. Notice they've only got 2x written right down here. That natural log of e is gone. Why is that? Because, remember, that's an e there for natural log. Remember, if I look at this right here, then natural log of base e of e equals what? Remember, if I change that to exponential form, that'd be e to what power equals e. Remember, this e is a 1 right there, so this is 1. So the answer is 1. Natural log base e of e is 1. That's why it's gone. 2x times 1 is 2x. Okay, so anytime you have log base b of b, that equals 1, or natural log of e equals 1. It's the same thing, okay, because this is e. The base and the x value are the same, boom, automatically equals 1. You need to have that memorized. All right, so that's the reason we're taking the natural log, because it cancels this out to 1 right there. And now we can solve the equation. Last step, divided by 2, or the same thing as multiplying by 1/2. So I can put 0.5 in my calculator. Natural log of, now when I do this, I need to make sure that 8 divided by 3 is in parentheses. Okay. And there you go. And then there's your answer. All right. Let's go to example B here. So again, remember in all natural logs, this has to be greater than 0. We got to check it, make sure it's greater than 0. That's why you see it's greater than 0 right there. I have 2 inequalities to solve. This one has to be greater than 0, and I also just solved this inequality itself. Okay. Now, they've used something different here. Okay. If you remember, we had b to the log base b of x equaling x, right? Meaning whatever's here, that is the answer. This right here equals 1. Okay, that's another thing that equals 1. And so whatever's here is here. So that's what they've done here. They raised both sides. They put e as the base and raised both sides. Whatever you do to one side, you do to the other side. And then since that's base e, that cancels out. Okay, as I just showed you over there, it's 1. And then so I get 4x minus 1 is less than e squared. Okay, or this part cancels out to 1. So you get 4x minus 1 less than e squared. Now, let's say you forget that. That's okay. I just change, anytime I do a logarithmic equation or an equality, I change to exponential form. So I put an e there. How do I change that to exponential form then? E squared, remember it's e to that power, e squared is greater than 4x minus 1. And then I get the exact same thing right there. E squared is greater than 4x minus 1. So as long as you remember to change the exponential form, that'll also work. But just know that other shortcut, this one right here, that helps also. Especially for calculus, because they'll show it and write equations and show and work that way as well. So you need to know both ways if you're going on to calculus, just so you know. So we solve that. Add the 1 across, add the 1 across. So you get that. Last step, divide by 4 on both sides. And you get that right there. Now plug in the calculator.
and you get that right there. Okay. Again, they're going to the 10,000 spot for the decimals. If it goes out that far beyond. Okay, 10 minutes.